Welcome, Beamers. This lesson is in nanomaterials and the nanoscale. So when we talk about the nanoscale, we're talking about 1 billionth of a meter, or 10 to the negative 9 meters. When we look at a meter, that's about the size of a hobbit. So a meter is approximately, the size of a small child. If you swim or if you have been working in the metric system for a while, a meter is probably, I think it's 2.37 feet. Let me see if that's right. How many feet in a meter? I don't ever do this conversion. 3.2 feet. All right. So about the size of a hobbit. And then if we keep going down all the way to a billionth of a meter, here's where we get a nanometer. And this is about the size of a glucose molecule. It's smaller than antibodies. It's smaller than virus. So coronavirus is approximately 100 times larger than 1 nanometer. Bacteria, red blood cells, other larger bacterium, fleas, even DNA are much, much larger than a nanometer. Some DNA, this is the longest. So when we start to get down to a nanometer level scale, we are at some of the smallest scales that we actively work with as scientists. So a lot of protein folding, glucose molecules, atomic level, all of these we talk about on the nanometer scale, a billionth of a meter, 10 to the negative 9 of a meter. So in looking at the size of a nanoparticle, a house, approximately 10 meters, a strand of hair, approximately 100 micrometers, or 100,000 times smaller than a house, which makes sense. Then 100,000 times smaller than that would be 1 nanometer of a single-walled carbon nanotube. These are increasingly used in engineering applications. They're really cool, but they're not what this is about. So we can also look at DNA. A regular piece of DNA, not a longest strand of DNA, would be about 2.5 nanometers in diameter, which is 1,000 times smaller than a bacteria. So, a common strep causing bacteria, which is 1,000 times smaller than a single raindrop. So go outside today, this afternoon when it rains, look at the size of a raindrop, picture 1,000 times smaller than that, and then picture 1,000 times smaller than that. So we already can't see bacteria with your naked eye, and that's 1,000 times larger than 2.5 nanometers. So nanometers are really fantastically small. If we look at the size of a speedway, such as Indianapolis Motor Speedway, 1,000,000 times smaller would be an ant, which makes sense, which is about 4 millimeters long, and then 1,000,000 times smaller than that would be a nanoparticle. So we use these carbon nanotubes or these little nanoparticles in a lot of engineering applications because they're so small and they have a really unique property when you get down to this size, this small. For instance, we use nanoparticles a lot in medicine, including there's people at FGCU who use this, including nanotoxicity, so how nanoparticles might be toxic to us, and also nanomedicine, so how we can use nanoparticles to better deliver medicines, such as in cancer, nanotechnology in cancer. There's also been a lot of research also at FGCU. This is looking in the digital repository of all the presentations that have been given by FGCU faculty. So here we're looking at silver nanoparticles and their toxicity on fish. There's other people who have looked at silver nanoparticles and their toxicity on fish, as well as nanoparticle photonics, coupling of single nanoparticle wavelengths and plasma, transport of nanoparticles. There's a lot of really interesting nanoparticle research going on at FGCU across the United States, across the world. When we look at using nanoparticles in science, there's two different games that we're going to play in this lesson. So they're both citizen science games. They've been developed by scientists to help gain more data about a specific research area. So in playing these games, you're actually helping research, which is really awesome. So the first one is called Quantum Moves, and it's where we look at moving atoms in a wave-like structure around. So um, your quantum moves is how we, as basic non-nanoparticle, non-atom scientists, can still look at how to move an atom from one place to the other as quickly and as efficiently as possible in a certain amount of time. So there's a whole intro video to playing this game, but in general, it helps teach you about quantum movement, the atomic scale, and helps kind of put into perspective how we might work on the nanoscale as scientists. The second game is going to be a game called Fold It, where we look at different protein folding configurations. And protein folding, we look at a lot as scientists in terms of um, toxicity and medicine delivery, all sorts of applications. So it explains it a lot more on the web page of this. I've also posted some additional videos for both quantum moves and Fold It, as well as links and information about download. So the nanoscale is awesome. It's powerful. It is really, really, really small, a billionth of a meter, 10 to the negative 9 meters. And I think it's a fascinating area of science and research. So I'm excited for you to play these games. Please email me or log on to Zoom with any questions, and I hope you have fun.